And this is your notes on section 3.3. This is going to be on the spread in the data or the variation in data. I did want to briefly just refer back to this concept of skewness. When data is single mode data, notice all three of these distributions peak just a single time. So when we have a single mode, typically that mode is equal to the mean and the median if we have symmetric, or if a single mode data is symmetric, that's usually bell-shaped data. Or if we have negative skewed or left skewed data, then the mean is usually pulled down further than the median. Right, now I'm saying usually, that's not 100% of the time, but usually it is. And then here, when the data is positively skewed or right skewed, the mean is being pulled up higher than the median typically. So that's something I was referring to back last time, and referred to in some of your discussions we talked about in class. Alright, so again, it's not always, if you see a mean that's bigger than the median, that doesn't necessarily mean it's right skewed. Okay, so just keep that in mind. Alright, measures of variation. This is the spread of the data. The basic concepts, the basic things that we use to measure the data, spread in data, are the range, and then of course the standard deviation. So the range, the most basic, very simple. It's just your maximum value minus your minimum value. Alright, but of course it's very sensitive to extreme outliers, just like the mean is, and it's not that great of use as a measure of variation. Alright, this is typical for when we do measures of variation. We usually go one more decimal place than the original data set. So if our data set is stuff like 3.2, 4.8, 5.7, etc., etc., then we would take our range, our range or our variation, standard deviation, to something like 2 decimal places, like just hypothetically 1.57. So we'd have one more decimal place. Alright, and then always round at the very end. Don't round each step of the way in these calculations we use to compute variance and standard deviation. Alright, the standard deviation sample values, we use S to denote that. Okay, that's easy to remember. It measures spread, how the data is compared to the mean, how it's changing or spread around the mean. So this is our formula for sample standard deviation. Alright, notice this is for sample. We're going to have a formula in just a second for the population standard deviation. So there's our sigma notation. Okay, so what's going on here is these x's are your measurements. And that's just your data set, whatever your data is. And so what we do first is we find the mean. Okay, there's the mean. And then if you look, that's in a parentheses. So order of operations dictates how we do this. We find the mean first, and then we subtract that from the data set. You subtract the mean from the data points for every single data point. Alright, and then you square that, meaning you square all those differences from the mean minus the data values. These are called deviations, right, from the mean. This is a squared deviation. And then you add up all those deviations. Okay, add up all the deviations, squared deviations from step 3. Divide by n minus 1, alright, and then that's got everything underneath this square root symbol. And then finally the last step is take your square root. Okay, so this is the process step by step to do this. Find the mean, subtract the mean from all the measurements, square all those differences, add up all those squared differences, divide by n minus 1, and then take the square root, and there's your standard deviation. Alright, so let's practice this. Alright, so here's our data set 3, 5, and 3. So if we look at our definition of what we do first, we find the mean. Okay, so if I find the mean of 3, 5, and 3, or 3, 5, and 13, that's 3 and 5 is 8, plus 13 is 21. So 21 divided by 3 is our mean. So that's 7. So the mean is 7. So what the next step says to do is take each measurement and subtract the mean. So I'm going to subtract 7 from all of these values. So I get a -4, a -2, and a 6. Okay? After that it says to square these values that we just came up with. So I'm going to square -4. That gives me +16. I'm going to square -2. That gives me a +4. And then I'm going to square 6. That gives me 36. Okay, oops, wrong one. Alright, and then after I've squared all the values, I add them up. So I add these values up. So 16 and 4 is 20, plus 36 is 56. So I add all of those three squared deviations up, I get 56. Alright, and then it says divide by n minus 1. Well, n is your sample size, so that's 3. There's 3 values here. N minus 1 would be 2. Alright, so 56 divided by 2 is 28. Alright, and then the very last thing it says to do is take the square root. So going back here and taking the square root of 28 will give me my standard deviation. So square root of 28, 5.29 roughly. And using that rounding thing, since our data set all contained no places after the decimal, we would round to one place after the decimal. So in this case I would round this to 5.3 using those rules of rounding. Alright, so that's the formula. And if you notice, we take our data set, we found our mean, subtract the mean. Alright, don't worry about positives and negatives because once you square, they're going to go away. Alright, everything's positive. Now we add up these squared values and then take that thing, divide by 1 less than the sample size, and then take your square root. That's the standard deviation formula. Now this is it's a shortcut formula where you can it's less sensitive, especially when there's a lot of data values, to get that quicker. Alright, notice the parentheses in and out. This says square all your values first. This says add up the numbers and then square them later. So you're welcome to use this for either. I'm going to show you now how to do it on your calculator, so it really it's not a huge deal to do it by hand with the original formula for the data sets we're going to do. But just note this one is there for larger data sets. You're welcome to pause the video, write that down, and practice using it if you're wanting to try it. Right, but I'm going to take this original data set and 3, 5, and 13. I'm going to put that in my stat editor. So press stat, hit enter for the editor, put in your data. So 3, 5, 13, and then once you're done, you can get the standard deviation under the 1 bar stats as well. So stat over to calculate, and then 1 bar stats is what you want. Now again, remember, the cursor here is waiting for you to put a list in there. If your data is in list 1, you can just hit enter. If it's in another list, you need to tell it where though. Alright, now notice that this is our answer, 5.29, roughly 5.3. You can also compute the population standard deviation, which we'll do in a second. It's up to you, the person putting in the data, to know which one of these you need. If it's a sample, You're going to use this one, that's why it's on top, because it typically is a sample, but it could be a population, and that one's right here below it. So I'm going to go down another couple slides and show you the population standard deviation formula. And just note that if your data set is a population, then there's going to be less variance and variation in the data set because of the fact we have all the data values. So I'm going to treat that same data set this time as a population, 3, 5, and 13, and follow this formula. Okay, same thing. I subtract the mean. Remember, this is population mean. I subtract the mean from the measurements, square that, add them up, but this time I only divide by n instead of n minus 1 before I take that square root. So the only thing that's different, alright, we know that this adds up to 21. So we know that the mean, this time we use mu because it's a population, we know that the mean is 7. So when I subtract 7 again, I get the same thing as I did before. So when I square, I'm going to get the same thing as I did before. I'm going to get 16, 4, and 36 because it's no different all the way up until we divide after we take this sum. So I've got 16, 4, and 36. When I add these together, I get a 20, and 20 plus 36 is 56. But now when I divide, I don't divide by n minus 1, I divide by n. So this time I divide the 56 by 3. Alright, 56 divided by 3 is 18 2/3. And then when I take that square root, that's when I get that 4.32 number. Alright, so that's where that's coming from. So 4.3 roughly, again, using the rounding steps that we talked about before. Alright, so those are the two different standard deviation formulas that you'll see. Your calculator gives you both. Okay, your calculator gives them both when you do the one variable stats, but your calculator doesn't know which one, or if the data set you put in is a sample or a population. So it's up to the user, the person putting it in there, to know which one of these things to grab off of the calculator.